Okay, I'll go through this fairly quickly, so you might want to pause the video here and there to make sure you understand what's going on. This is actually the law of sines ambiguous case because we're given an angle, a side opposite, and then one of the sides included in the given angle. The way I always do it is I set up the angle first with one of the rays horizontal and try to estimate about 24 degrees, and the side opposite is kind of like it's hinging out here. We don't know yet if it's going to hit the opposite side or not. To find out, one way to do it is to determine the length of this altitude, dropping an altitude that is perpendicular to this ray, and calculate it using the right triangle. The sine of 24 equals h over 32, so h equals 32 times the sine of 24. So let's say this was about 13 after that calculation. If b is less than 13, that's when you get the DNE. It does not exist. There's no triangle because this side's not long enough to hit the opposite side. If this side is longer than 13, it's going to hit here. And then if you picture it rotating this way, as long as it's less than this 32, it will hit again. That's why you have two triangles. Okay. If this side opposite happens to be greater than 32, then it won't hit over here again. You'll only have one triangle. Okay, so here's what the triangle looks like. Here's where I've actually calculated the altitude. And now I can use the law of sines. I've circled the given information here. We've got angle B, the side opposite, and one of the included sides. So the sine of 24, this angle right here, is to the side opposite as, well, we know side C, so we have to solve for angle C. Sine of C is to 32, so the sine of C equals 32 sine of 24 over 28. C equals the inverse sine of this right here. And if you do that calculation, your calculator will give you 27.7 degrees. And then we can solve for the other parts given that this angle is 27.7. But you have to realize that there's another angle between 0 and 180 that has a sine that's this value, whatever it is. And that's 180 minus 27.69. In other words, if you think of the unit circle, these two angles, didn't draw that very well. This angle and this angle have the same sign on the unit circle, where the sine is this y coordinate. So we'll get into the second triangle in a second. How do you find the other two pieces? Well, once you know two angles, you can find the third angle. That's where we got this 128.3 degrees. And then once you know that angle, you can use the law of sines again to solve for side A by saying 28 is to the sine of 24, as this side that we don't know yet is to the sine of 128.3. So A equals 28 sine of 120.3 over the sine of 24. Okay. Now, we still need to solve for the second triangle. So what you want to do when you do a problem like this is organize your work into triangle 1 and triangle 2. So we just did triangle 1. I think the directions on your problem were to solve for a sub 1 and a sub 2, where a sub 1 is less than a sub 2. That's what we're going to show over here. The other possibility for angle C, remember, was 180 minus that 27.7. But if that's what angle C is, then angle A is 180 minus the given 24 plus 152.3. And that turns out to be about 3.7. And once you know that, you can solve for this missing side right here by saying, once again, 28 is to the sine of 24 as A, the side we don't know, is to the sine of 3.7. Okay, so what you want to do is organize your work, triangle 1, triangle 2, write down all the missing pieces here, maybe even include the given information. There's 3 missing pieces and 3 given pieces. And then do the same thing over here for triangle 2. Okay, there you go. Hope that gave you some idea. If you have any questions, post a comment.